Hello everyone. In this video, we are going to calculate the pressure of gas in a container. Our final result will be we are going to derive this relation. The pressure is equal to 2N divided by 3V, the average kinetic energy, which is the basic relation for the thermodynamics, and we can derive the Boyle's law and the Charles law from this equation. The first of all, we consider a container of a volume L cube, and there are large number of molecules. Consider simply one mass, simple m1 mass, which is moving in x direction. Let's consider molecule, single molecule of mass m. Note that if we are going to calculate the pressure of a gas, we should know that the pressure is equal to the force per unit area. And first of all, we have to calculate the force and the area, then we can calculate the pressure of a gas. And force can be calculated by the Newton's second law in terms of momentum, which is the rate of change of momentum. So first of all, to calculate the pressure of a gas, we calculate the change in pressure of a molecule moving in a container. We consider the mass m of a molecule m which is moving in x direction, only in x direction. Its velocity is v1 x. 1 means the first molecule and x means in x direction. Its initial momentum p initial will be equal to, as the momentum is the product of mass and velocity, the mass m and its velocity is v1 x. And its final momentum after the collision with the wall, it collide with the wall this, and it will bounce back with the velocity minus v1x. The final momentum will become the minus m v1x. Now change in momentum is equal to the final momentum minus initial momentum, and the final momentum is minus m v1x, and the minus initial momentum is m v1x. Now change in momentum will become the minus 2 m v1x. Now we find out the change in time interval. The time, this is time between the two successive collisions at this wall. The molecule strike here wall and then goes back to the other wall and strike this wall and will come again at this wall. This wall, two successive, the time required, we have to calculate the time required between the two successive collisions, and we know that the time t is equal to, for the basic equation, S is equal to Vt, and the S is the distance, V is the velocity, and T is the time. We can calculate that T is equal to S by V. S is the distance traveled by the particle and V is its velocity. And we know that the distance traveled by the particle is, as this length is L, it goes to this wall. Say this is wall 1 and this is wall 2. The molecule go from wall 1 to the wall 2, and then it comes back to the wall 1 again. The total distance traveled by the particle is 2L, and its velocity is v1x, only in x direction. We're considering only x direction. This is the time and this momentum. Now we are able to find out the force, which is only in just x direction. Fx is equal to the delta p by delta x, and delta p is minus 2m v1x, and divided by 2l divided by v1x. The 2 and 2 will be the cancel out. The force along x direction will become minus m v1x square and divide by L. Now we have a question for you. Is this force F1x is a force of molecule on wall, or it is a force by the wall on molecule? The answer is, as the momentum is changed by the wall of molecule, then hence it is force of wall on molecule. And if we are going to consider the force of molecule on wall, then we have to apply the Newton's third law, which tells us that the both forces are equal in magnitude but opposite in direction. Then the force F, this force is on molecule by wall, and if we want to calculate the force of molecule, then it will become F1x is equal to minus into minus m v1 x square divided by L. Because the both forces are equal in magnitude but opposite in direction, this minus and minus will be cancelled out and we will get the F1x is equal to m v1 x square divided by L. As there is not a single particle, there are the capital N number of molecules, then the total force will be calculated as the F1 Fx is equal to F1x plus F2x plus F3x and then plus so on the Fnx n number of molecules. The F1x we calculated m v1 x square divided by L and plus m v1 x square divided by L sorry v2x square and plus m v3x square and divided by L plus so on the n terms. Now Fx is equal to m over L is common from the whole equation. We will get v1x square plus v2x square plus v3x square plus so on vnx square. Now we can calculate the pressure of a gas by from this equation. The pressure of gas Px is equal to Fx over area and Fx over L square. Area is L square. Area of the ball L square. We have calculated the value of Fx. We will plug this value in this equation. We will get Px is equal to Fx value is m over L into v1 x square plus v2 x square plus v3 x square plus so on and vn x square and divided by the whole value will be divided by L square. And now Px will be equal to m over L cube into v1 x square plus v2 x square plus v3 x square plus so on vn x square. Say this equation is 1. As we know that the density of a container or some substance is density rho is equal to mass divided by volume. Now the density of this container will become the mass, total mass of this container is the small m is the mass of the single molecule and multiply with the total number of molecules will become the mass of the container, the mass of the gas in present in container and the volume is L cube. Here the density divided by total number of molecules will become the m over L cube. And this, we will plug this relation in equation 1. Plug this equation relation in equation 1, we will get the Px is equal to density divided by total number of molecules into V1 x square plus V2 x square plus V3 x square plus so on and Vn x square. The Px will equal to the density. This n will be divided by divide in this bracket. We will get the V1 x square plus V2 x square plus V3 x square plus V plus so on Vn x square and divided by capital N. This capital N is the total number of the molecules and the addition is also the n terms. Then if we divide the sum with the total number of terms, we will get the average value. The Px will be equal to the density and the average value of the Vx square. This is our the result in x direction. Now we know that the particles are moving randomly. They move in x direction, y direction, and then z direction. Then the velocity is not only in x direction, it will also in y direction, z direction, and we will find out the average velocity v square is equal to by the vector sum. We know that it will be equal to the vx square plus vy square plus Vz square, and we take the average of all the terms. As there is no preferable direction, x, y, and z, all directions velocity will be the same. The Vx will be equal to the Vy will be equal to the Vz, as there is no preferable direction, then then Vx will be equal to Vy will be equal to Vz. Z direction, our relation V square average will be equal to Vx square average plus Vx square average plus Vx square average will be equal to the 3 times of Vx square average. And the Vx square average will be equal to the 1 by 3 of V square average. We plug this relation, this equation in our this result, the Px. Now we will find the Px is equal to density into 1 by 3 into V square of average. And this pressure is along x direction. We will consider here Pascal law, and according to the Pascal law, the Px is equal to the Py is equal to the Pz and is equal to P. The pressure in x direction is equal to the pressure in y direction and z direction, and it is also equal to the any point, the pressure at any point in a container, which is general at P. Now the P is pressure is equal to the density divided by 3 into V square average. The density is also equal to, here we find the relation of density is equal to mn over L cube. We plug this value again. The P is equal to density is equal to mn over L cube. The L cube is the volume and it is V square average. We rearrange this equation by the P is equal to multiply 2 n divided by 3V. As we multiplied 2 with our side and we have to divide by 2, the 1 by 2, this m goes in bracket, then mv square. This relation becomes the average kinetic energy, and we will get the pressure is equal to 2n divided by 3v, the average kinetic energy, which is our final result of pressure we want to derive. And you can take the screenshot of this whole lecture from here if you can. Thank you for watching.